So continuing on in lesson 4.6, as I said, this is going to be the last thing that we cover in it. If you were given the slope and one of the points on the line, not the y-intercept, you can use the slope-intercept form. What is our slope-intercept form again? Y equals mx plus b. We can use that to find the y-intercept, because if we know the y-intercept and we know the slope, then we can write the equation that would represent that line and any ordered pair on it, not just the one we were given. Okay, so let's practice with this one. Write the equation of the line whose slope is -4 and ordered pair -1, 3 is a point on it. So we're going to substitute into our y equals mx plus b, and I'm pretty sure that right now at this point we know how to solve an equation for as long as we only have one variable left to solve for. We can get a value for that variable. We haven't learned how to solve when there's two variables involved yet, but we know how to do one. So if we can replace, we got how many variables do we have in our slope-intercept form? 4. If we could replace 3 of those things, we should be able to solve for the 4th, right? Okay, so do we have 3 things?
Yes.
Yeah, what's our y value? 3. So we're just going to follow across the equation there. We can put in for y. So we could put 3 in for y. What's m? Do we know m? Or is that what we're going to have to solve for?
-4.
-4. So we know m. Do we know x?
-1.
That's -1. Do we know b? No. That's what we're solving for, isn't it? We're going to solve it for b. So we have to leave b in there and now get our equation solved for b. Okay, so let's go about doing that. 3 equals -4 times -1? 4. What do we do to both sides now? Subtract 4. 3 take away 4 is? -1. And the b is now by itself. So we now know our, what is that? Y-intercept. Okay. So remember, that's what we were given yesterday. We were either given the slope and the y-intercept, and then we were able to write the equation and or graph it. Or we were given the equation in standard form, we rearranged it so it was in slope-intercept form, and then we could pick out the slope and the y-intercept. So even though we know one of the points on the line, that's not going to be in our equation on the line. That's just one of the many solutions to our equation. What would be the equation of the line that ordered pair -1, 3 would actually be a solution for? What do you think? Right now you're acting like you didn't SQ3 or lesson 4.6. Maybe you should open to your SQ3 option. Because I could just tell you what the answer is here. We could fill in the blank and move on, but I'm thinking that you should be able to fill in the blank for me. We just found the y-intercept. Did we know the slope? Do we have enough information to write the equation of the line then? Absolutely we do. What is it? Y equals
-4x
-4x
plus
-1. Cleaned up, that is? Yeah. Y equals -4x minus 1. Now, what's confusing about this is you might feel like, well, don't we need that -1 and that 3 in there somewhere? No. That's one of the many solutions to this equation. Just one of the many. We just used it along with the slope to help us find the y-intercept. So here's the equation of the line. Now let's just graph it to verify it, okay? So -1, 3, and what's the slope of our line again? -4. Okay, what I mean by verifying it, let's see if the graph actually crosses the y-axis at -1, okay? So we're going to graph it like I just talked about at the beginning. Could we graph this with just the point and the slope that we have? And we said yes, we can. We would go to -1, 3. I'm pretty sure this is what you told me. We could put that point on the graph. And then we could use our slope of -4, which means we can either go down 4 and over 1 to the right, or we can go up 4 and 1 to the left, right? So one of them has to be negative. So from that, let's make 2 more points. So up 4 and over 1 to the left, or down 4 and over 1 to the right. Well, looky there. Where are we? You're going to need these today anyway, so let's get your rulers out to you. Where is it crossing the y-axis at? Oh, at negative. It's crossing the y-axis at 0, -1. The y-intercept is -1. So draw the line through your graph. So we just verified that the algebraic process we used gets us the same y-intercept we would do if we actually graphed it. Remember, they're all related. The equation is related to the line. All those points that are on the line are in the table. Okay, now what I want you to do is I want you to pick another point on that line. What if we had used another point? In other words, what if we had used another point to find the y-intercept algebraically? Would we get a different y-intercept? Would you pick another point that's on that line besides the one that was given to us, or the y-intercept? I don't want either of those. Courtney?
1, -5.
1 what?
-5.
-5. So in other words, if we go down another 4 and right 1, we have 1, -5. Okay? So we're going to put -5 in for y, our -4 in for slope, for m, +1 in for x, and we're going to solve it for b. So we have a -5 equals a -4 plus b. And to get b alone, we add 4 to both sides. -5 plus 4 is -1. So our point being, if this point is on the line, that line can only have how many y-intercepts? 1. That line, that equation can only have 1 y-intercept. It does not matter which point we use from the line, along with the slope, to help us find that y-intercept. We better get the same answer every single time, right? That line only has 1 y-intercept. So right now, we know a few of the points that would be in that table, and we could find a lot more because there are an infinite number of them. By the way, our only points that have integer x values and integer y values, are they the only ones that are solutions to this equation? In other words, you have your line drawn, and somewhere like right in here, you put a point on that line, and it wouldn't have an integer x or an integer y value. Does that mean it's not a solution? No. There are actually non-integer x and y solutions, ordered pairs that won't have. It's just that, we don't typically look for those very often. But they are there. They're part of the solution set. Okay, so any questions about how do you write the equation in slope-intercept form, given a point and the slope of the line? Now, when you're doing that, you don't have to necessarily graph it to verify it and try another point like we did. We were just kind of exploring and making sure that we understood that the connection all of it has. Okay, then let's go to the back side where we're going to do an application problem. Okay, we got a caterer that charges a $200 fee plus $20 per person served. It says write an equation that represents the cost as a function of the number of guests. So is cost X or is cost Y? That's Y. As a function of the number of guests, so that is, what's our X then? The number of guests is our X value. So the number of guests controls what the total cost will be, right? Okay, so what would our, what do you think our equation would be for this one? Y equals 20x plus 200. X is the number of guests. Each guest has to pay, you have to pay $20 for each guest that you're going to have. The plus 200 is the catering fee, the one-time thing they charge no matter how many guests you have. You have 2, you have 20, it doesn't matter to them, so they're going to charge you $200. So what's the slope of this line? 20. So, and what's the y-intercept? 200. And remember, the y-intercept is always when x is equal to what? Abby? 0. So in other words, you can have, you can say to them, I just want you to cater for me. And they don't even ask you at that point how many guests you're going to have. They say, okay, no guests involved, I'm just going to cater for you, it's $200. So at the start, the cost is $200. No guests, $200. But then after that, what happens? For every guest you invite, it goes up $20. So 20 over 1, the rise for every $20, the cost goes up $20 for every one guest that you invite. Okay, so now let's graph that function and write out in words what that slope and y-intercept really represent. So go ahead and finish first of all numbering. I've already picked the scale on the x-axis. We're going by what? What's the scale on the x-axis? 5. And what's the scale on the y-axis that I chose for us?
100.
100. So it makes we need to make sure that we make it easy for someone who's reading it. I'm going to do every other one because it gets kind of fat on here. But I should do it properly. Okay, so where are we going to start? Where's our first point going to go? I just, it's still going by 5s. I just skipped to grid lines because my numbers would get too close together there. So where are we going to start? At 200.
Oh, for the cost.
On the y-axis, yeah, for the cost. So we're going to start with putting a point at 200 on the y-axis. So B is 200. That's our starting one. What's our M? What was our 20? 20 over 1? Okay, now, tell me something about it. We're going to use the slope as 20 over 1. Do you like it? With our scale? I wonder what we could do. We could rename that, couldn't we? We could say, you know what, the x's go by 5, so let's get those x's so they're going to, let's start there. Let's make those x's become a 5, the run become a 5, because that's what every grid line is. Well, if we multiply downstairs by 5, we're going to multiply upstairs by 5, so that becomes 100. Is that more user-friendly? In other words, we have to go up 100 and over 5. Can we do that easily? Yeah, I like that one better. So now we're going to go up 100 over 5. Up 100 over 5. On these, I suggest you make a few points. It's not hard. Make a bunch. And even though this is a discrete graph, we are going to connect it with a line. We are going to put a line through it. We know it's discrete, but So we have an arrow at the one end, right, but not the other. Okay, now it told us to tell what that slope and that y-intercept represent. So let's start with the slope. What does the slope tell us? Abby?
$20 a person.
Yeah, the slope represents the cost per person. We don't even have to say the 20, it's okay. Represents the cost per guest. Per person. That slope is telling us that for every, you pay $20 for every one guest you have. Or, another way to say it is you pay $100 for every 5 guests you have. Or there's lots of ways we could say that, couldn't we? Okay, then what is the y-intercept representing?
Catering fee.
The catering fee, yeah. So the y-intercept, remember sentences? The y-intercept represents the catering fee. Doesn't even matter how many guests you have. When there are no guests at all, it's $200. So at the start, it's a $200 fee. So the y-intercept represents that catering fee. Okay. Now it tells us to find the cost of catering an event for 200 guests. Now, there's a couple of ways we could do this, actually. If our graph allowed it, we could go to the graph, we could go to x equals 200 and follow it up to the line and make an estimate of what we think the cost would be. Can we do that? Why not? Doesn't go up far enough, does it? Okay, 35, 40, yeah, with up to about 40 guests, that's not very useful. What's the other way then we could do it? Plug it into the equation, right? What's our equation? Y equals 20x plus 200. We're going to have 200 guests. One big party. We don't even need a calculator for this. 10 times 200 is 2,000. Double that, 4,000. So y equals 4,000 plus 200. Well, how hard is it to add 4,000 and 200? Better not be hard, right? So what is our $4,200? Okay. So sentence answer, here we go. What will we say?
Cost of 200 guests is $200.
Yeah, the cost for 200 guests is $4,200. Any questions? So don't shortchange your word problems, your application problems in your homework when it's asking you to tell what things represent, and then we have to find something. Remember, we got to keep practicing this writing sentence.